Hey guys, welcome to DevOps School.
But before we begin, let me inform you few things about us. DevOps School is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
Okay, so guys, the first question which I'm having in my mind is what is Terraform? Okay, that's a very first question, and I would request you to let's focus on this session, all of you, because let me tell you here in a simple way: if you miss one session, one part of it, then remaining other sessions also it will be very difficult you to understand and grasp it, because we have 5 days. We don't want to waste any sessions. On top of it, we have given sufficient time for the break also, so which you can use for your personal or official other work also. Okay, and I would request you all to be participating in the sessions, in discussions and demo and lab, so that will be effective for us. So we, these 5 days we should finish the Terraform on Azure platform, and after that there's no time you should be spending for learning rather than implementing the things. Okay, it's not very difficult tool. Okay, so
Yeah.
first thing is, what is Terraform?
Rajesh, sorry, I just joined. So did I miss anything before this starting Terraform?
No, it's the first question which we are going to start with. We have not missed it. Okay.
Okay.
So what is Terraform? So whenever I ask someone like you or anyone else, my colleagues and anyone in the industry, or I Google it, everyone say, hey, this tool is a code for infrastructure as a code, IAAC. That means infra as a code. This tool for the coding for infra. If I put it up in more simple way, this will be coding for infra. Okay, coding for infra means what? So I'm still not able to understand what does that mean, coding for infra. So let me put it up one of the contexts. I hope you remember that. In DevOps, we have a very simple rule, and rule is very simple. That is like, if you are a DevOps, you code for product, correct? Code for the function of the product, or I'll just write code for the product. You need to code for it. If you're a DevOps engineer, and if you understand the right context of DevOps, you have to code for the product as a team. Not I'm saying individually you have to do everything. As a team, there is only one team which is called DevOps team, and that team has to do everything, what including the code for the product and code for testing a product also, testing a software. Product, software, all are same thing right now in my context. So you have to code for testing a product also. And then last one, code for CI/CD. Some of you might have done it. Code for pipeline, code for operations, code for infra. So here, the part which I'm discussing right now is code for infra. Okay, but this is clear, right? If you want to implement the DevOps, I'm a DevOps engineer. I'm a part of the DevOps team, and my team is supposed to do everything in terms of coding for the product, coding for the testing the product, coding for the CI/CD pipeline operation and infrastructure. So literally in DevOps, everything should be coded. Everything should be coded. Okay, so that should be clear. So here, primarily our session is around infra coding, coding for infra. Okay, so this tool is for coding for infra. Now, next question I'm having in my mind is, what is there in the infra, right? What is there in infra? So we need to code for it. What is there in infra? So This question I will not answer. I would like you to tell me in infra what you find actually. Infrastructure, what you find. You see, I assume you are from the dev background or QA background or operation background. So what you find in infra? Because dev infra, QA infra, operations infra, production infra, almost all you must be aware of it. So what you find in infra?
VMs.
Or obviously
VMs
virtual
network.
machines, networks, storage,
Yeah, VMs, network, storage, right? All these things.
databases,
Databases. What else?
like
Services.
Security
Se-
configuration.
security configurations. Yeah,
some task service configuration.
yeah. Some work. Yeah, some work. Some tasks. Some jobs. Yeah.
web
And
apps and all,
Sorry.
yeah.
Huh?
web apps.
Yeah. Web apps.
Like there are many actually, right? Web apps, REST API, API management,
Yeah.
gateways.
Many things are.
So yeah,
Cloud
many
we have.
things.
Cloud we have.
And
Apps
also
we have. Multiple software we have. Right?
Load balancer.
Load balancers. Yeah. All these things we have.
Gateway.
Yep. Gateway. So now you understand that what we have in infrastructure. We have so many components in infrastructure. Now, as part of the DevOps implementation, what we want to do, none of the things it should be done manually. None of the things it should be done manually. That means if you want to create a dev environment, you should be able to do that through the code. Now, dev environment, you may require all this compute, storage, network, security, apps, software, VMs, this, that, and all. So it's okay, but it should be done through the coding. That means I should run that code, and then dev environment should be created. And then if I want to delete only my environment, I should run the same code. Or if you want to create a test environment, I should run that code. And then if I want to delete it, get rid of that through the code itself. Or operations, same thing. So production, same thing. So here, what I'm trying to say is using Terraform, we are writing code for infra, and infra has so many components which we have already discussed and knows about it. So using that, you can code for infra. That means using the code, you should be able to set it up everything. Okay. So yeah, at least I got a little bit of idea what is Terraform now. Okay. So we will discuss a little bit more about infra in later point of time. Now this tool, you know what? This particular tool is written in Golang. Okay, Golang. That means if you want to, uh, you know, automate something, if you want to modify something, I think Go language is a customize something. I would say Go language would be the best suitable programming language. Now, this tool is from the company which is called HashiCorp. Okay, HashiCorp is the company from where this tool has come. HashiCorp. Now, HashiCorp, if you look at the company as a company, they have multiple products actually. And I must tell you here, all of their products are very good. One of the products what they have is Vagrant, starting with. Then they got Terraform. They got multiple tools. Console, they got it. Then Packer, we got it. We have Nomad, we have Vault, we have so many products. They have more than around 8 or 9 products. So I must request you all to spend some time today on their website also. This is the organization which is one of the fastest growing organizations in Silicon Valley. So yeah, that is a good to go ahead with. So this product is from the HashiCorp. Okay, now they have a multiple releases also. They have a multiple releases. What releases? So there's one release, I would say community release, and then there is one other release, we call it a cloud release, and then another one we call it enterprise release. Okay, enterprise release. So these are the 3 release they have it. I would like to Sure, just a second. This pop-up is not going. No. There's a way to hide this pop-up, right? Anyone have idea that like how to hide this pop-up?
Which pop like?
There's one pop. Okay, I know it's got up. Yeah.
Yeah, there is
There's
a
a
close button, right?
yeah, I did that. Okay, yeah. Anyways, it's gone. So here, this is the Terraform website. There's IO, and here it is. So here you see that it's a open source, and here
Rajesh,
you
your
have
screen is not
I
replicating.
think it is not getting sync with us. Like I can
what is it?
see the economic times.
Or is it?
Within
Just
the
a second.
group.
Yeah, same here.
Yeah, same here.
Just a second. Let me share one more time. Is it visual to everyone?
Yeah, it is now.
Yeah. So the moment I start sharing, oh, there's one pop-up is coming. I think I should learn to disable this. How? I'll try a little bit later. Uh, yeah. So can you see my screen, all of you?
Yes, we can.
Yeah.
Yeah.
So here, if you see the Terraform, they have a release which is called open source and the cloud release. Okay. And these are the features what you have. Now, if you go and click on the download, here you have you see that Terraform is,
What is the difference between those two?
yeah, we'll discuss in some time. So
Okay.
if you look at this here, you have a sum of the answers automatically. That means because it's a Go, so Terraform can be installed in any platform because Go also is a platform independent. So you can install in Mac, you can install in Windows, you can install in Linux, you can install in FreeBSD, OpenBSD, and Solidus. Now, the latest version which you have is 1.2x. Okay, so the version in terms of the one which you are learning is 1.2x. So that's a thing. Now the question is, what is the difference between community version, cloud version, and enterprise version? So I'll put it in a simple way. Community version, the one which here we saw, is open source. This is the one self-managed. See, and always free. I think you got an answer. So here, understand that this community version is CLI version actually. CLI means command line version, and also it's a free. It's a free and it's a open source. Simple. Now, community version is good for the projects where the control is, I mean, entire control is done by individuals, not as a team, large team or something like that. So in that case, it's a very good scenario. Community version is very good. But when you have enterprises, multiple projects, products, multiple teams, hierarchy of the team, different kind of access level, and organization. When it comes for the organizing the organization, enterprise need those features, right? Security, authentication, multiple level of auditing, logs, and many things they need, right? So when you need that kind of feature, then you can go for the cloud. Now, cloud, this is the hosted solution. Cloud means, when I say cloud, that means Google, Gmail is a cloud, right? Cloud where we are using. So this is a software as a service, we can say, where you are using everything which is hosted at the cloud. Okay, for the enterprise, hosted is a paid services and is for the enterprise. Now, enterprise has a multiple challenge, okay, and that is fulfilled by cloud version of Terraform. Now, this also will cover as part of this session. So we'll do that one by one. And so now the next question you may ask me, what is enterprise then? So what is the difference between cloud and enterprise? So there's no difference actually. Uh, when you go for the cloud, you get some software, okay, UI based software. Using that, you can manage all the Terraform infrastructure through the Terraform. Now, same software if you want to install in the behind the firewall means within your organization, then you can do that also. So enterprise version of Terraform means it can be installed, same version of cloud in your infra, in your inside your infra. So that's the only difference we have in the cloud and enterprise. All of you are understanding? Hello?
Yes,
For
yes, yes.
Is
enterprise,
that something like the enterprise version we can use it in a local infrastructure and the
Yes,
cloud is
that's what
only?
I'm saying. Enterprise is a copy of the cloud itself, which you can install in your company, organization, in your server. Actually.
and
Okay.
it will be completely managed by us.
Yeah, of course, it will be managed by you.
Okay, because cloud version is a PaaS service, which is end-to-end managed by a service provider. For enterprise, since if I have my own restriction for my security standpoint and other things, so it's completely managed by us, and it is
Yes.
hosted in within our
Yes.
data set.
That's correct. Yeah, that's correct. Okay. So in the future, in the second or third day, we'll try cloud also, and one day we'll have an enterprise installed also. Okay. So this is the three release they are making here. So yes, when it comes for the Terraform, yes, it's a code for infra. We call it IAAC infra as a code for it for this purpose. This is written in Go by HashiCorp, and the multiple releases are there. I'm teaching you to start with community one, and this is the version latest one which we have. Okay. Now, so I believe this question about that what is the Terraform, we have got little idea about this one. Now, next question all of us is having in mind. Okay, I understand that Terraform is coding for infra, but still I'm not convinced why we need Terraform. Why we need Terraform? So, do we have an answer for it? So, I'll tell you in a very simple way.
It's a multi-cloud solution.
Yes, yes. You answer one of the questions. So let me write it. It's multi-cloud platform. So here I will go for only one page. Okay. Uh, uh, I'll go for only one page, which will give you all the answers. So here we understand that using the Terraform, we can write a code for infra. But if you look at this here, there's only one region, and the region is Terraform providers. Okay, well, there's only one region. And I would like you to read that here, this number. What is this number? I hope it's visible for all of you. It's a 2255, correct? No? 2255. That means Terraform, using the Terraform, you can code for 2255 tools, platform, applications, and so on. That's one of the primary reason we are using Terraform. Primary reason. That means this many supports you have. That means you can write a code for entire ecosystem. Okay, that's kind of support we have. So 2255 tools platform, and you know what? Every week is growing. I saw that starting from I think 100 something to 2250 or something like that. So look at this. Now you'll say, okay, Terraform is supporting so many tools. Okay, which are the primary one? So we should get and spend some time here. Of course, everyone should do that. Okay. And one request to all of you, always refer the official documents only. Why? Why I'm saying official documents? Because Terraform has grown from the 0.x to 1.x, and during this evolution, lots of changes have happened. Lots of changes. So, and it's a pretty much new tool which is popular from last 6-7 years. So, because of there so many releases, so many fast evolutions. Okay, so if you refer the Google, then you will find the old code. If you refer the official documents, you'll write a good code, a stable code. Okay. So look at this here provider list. We have these are the list of supported application and platform or tools or whatever you want to call it. See official one, verified one, community one. As names itself, if you read that, you'll understand that official one means is from the Terraform and officially written by Terraform or maybe the with the alignment with the Terraform HashiCorp. Verified means verified by the Terraform means HashiCorp and community one. And these are the category of support tools. And you see that multiple cloud supported. AWS is there. So AWS is the first one which they started supporting. After that, Azure, Google Cloud, Kubernetes, and so on. You see that pretty much huge list actually. And verify. These are the verified providers. So what I'm trying to tell you here, if you want to write a code for infra, and if you want the wide supports, okay, Terraform is the market leader in it. No one, there's no replacement for Terraform as of now. Maybe in future, if any, then I don't know. Okay, so there's only one reason, which is it is a supporting. That means you can write a code in easy way, 2255 tools, platform, apps, or something like that. Are we clear, all of us?
Rajesh, one question.
Mhm.
Just to clarify, this tool used for as a continuous deployment or CI/CD, both it is supported? Since
Okay,
you have
so
mentioned platform and apps, or maybe you are covering on the next, I'm not sure. Just I thought to ask.
yeah. So let me tell you here. This tool, the one which I'm discussing, we are discussing together, is can be used anywhere where you have infra. Simple. Are you having? Are you not having infrastructure? Infrastructure means some tools and some platforms, some applications, some services in development. Yes, we do have development team also have all this kind of infrastructure. QA team also use the same infrastructure. And operations also they use the same infrastructure, right? Let's say development also, I'm a developer, I'm using AWS or Azure. I'm a QA people, I'm also using AWS and Azure. Operations also using AWS and Azure. They have an environment different one, but we all are using almost common infrastructure, right? And the
Yeah.
requirement is very simple. We have to code for it.
Yeah. So I mean, it can be used for continuous integration as well as continuous deployment.
Yes, everywhere. It can be used. Let's say I'll put it in simple way. Let's say in during the CI/CD process, you want to do automated build and automated testing. So automated build and automated testing has to be done, and then immediate feedback. So automated build will happen in some infrastructure, right? Automated testing also will happen on some infrastructure, right? So that infrastructure building can be done through the Terraform also. Wherever the requirement has come to code for infra, this tool is perfect for it. Okay, so that is the things. So it's a very simple way. I'm just trying to put it up, not complicate the very huge keywords and which is so make it simple. Now next thing I understood that okay, what is Terraform? Then I also got to know okay, we are using Terraform because not of some specific love, but it has a wide support for the tools. So we are using this tool. Now next thing is how it works. That is a very important question. How it works. Now some of you also want to call it Terraform architecture. Okay, so do let me know Terraform architecture. Okay, so how it works. Architecture, there's spelling mistake, sorry. Just ignore it if you come across. How it works. So guys, right now for some time, let's not discuss about the Terraform architecture. Let's discuss something else. What something else? So I'll create one scenario for all of you. Okay, please understand. And also let's because I see we have a participant from the wide different domains and expertise also, right? So we will, DevOps is all about one of the practice what they say share, learn by sharing. Okay, that means we as a team, we all are from the DevOps team. We will learn not by teaching. I'm doing the teaching right now. No, it's not a good idea. By sharing. Okay, so let's do one. There's a one problem actually. I have one problem, and that we will as a team will find out the solution. And the solution is forget about the HashiCorp and Terraform. Let's say we as an organization wants to write a code. Problem is very simple. Develop a tool which can be used to write a code, one code, write a code means one language. I'll put it in this way. Put it in this way. Develop a tool which can be used to write one language and apply for thousands of tools, hundreds of tools for coding. I don't know how many of you have understood my question in a simple way. There are hundreds of tools which we have in infrastructure, hundreds of which. But that we have to develop that tool. So using that one language, I should be able to code for hundreds of tools, platform. So how do we do that? How do we do that? So that architecture we need to design. Okay. So for the discussion sake, I'm using some of the tools. So let's say this is the AWS. This is Azure. This is a Google. Sorry, this is the AWS. This is Azure. This is the Google Cloud. And this is the VMware. This is the Kubernetes. This is the Kubernetes. So these are the popular platform for time being, right? Very popular platform for time being. So AWS and Azure. Okay. Google Cloud, VMware, and last but not least, Kubernetes. Kubernetes is a very popular platform. It's become slowly, right? So now these are the platform. So let me ask you some of this question. If you want to code for AWS, then what language, what services you use? Anyone? I think we have a few people from the AWS background also.
Cloud formation we use.
Cloud formation, right? So that means, let's say if your project is using all five, then for AWS coding, AWS automation, you have to use the cloud formation. And what about Azure? Anyone? If hello?
Yeah,
So
Azure RM provider.
RM we have to use ARM. We have to use that, correct? If you want to use for the GC, some services for that also. VMware also some services. Kubernetes also there's some ways to do the what do you say? Coding. Kubernetes, what we do? Typically, we write a YAML file or a Helm package, correct? So the problem here is I have a 5 tools in front of me. That means I need to learn the 5 standards of coding, and that's like a too much of task for me. But let's say if you're in operations team or someone who's handling the entire operations, you may be having 30 platforms, 50 platforms, hundreds of platforms also. So are you going to write all these 100 languages, 100 specification, 100 ways to troubleshoot, 100 ways to test the functionality, debug the functionality? It's like so much of work actually. So we as an organization, we decided we'll write a product which will help this problem. So what do we do? Any idea what we'll do? What we should do? We have to fix this problem. That means human should write only one programming language. And understand that what I'm trying to say is very simple. Humans should write only one programming language. This is me, you, any ops engineer, DevOps engineer. Okay. So this guy will only write one programming language, and that can be run on any platform. So what should be done? We have few architects also. Let's design this system. Let's design this problem. What we should do? Tell me.
So since we have multiple platforms, so as we discussed, right, AWS has its own platform to and Azure, GCP, and Kubernetes. So it's very difficult to learn for multiple language, and we should find the common solution where all this service can understand the language, so easy to communicate, like cloud agnostic kind of things. So that's the only one thing, either if you see all platform is supported Java, Go, and Python. So this
Yeah.
is an overview about the all this platform can support. These are the languages. But since if I want to go for Python, then I should learn Python thoroughly. Then I can develop the product where it can support for multiple the
Yeah, but that's a problem, sir, right? That's a problem, right? Why should I learn Python or any other language? I don't want to learn. See, I'm
that
infra guy. I'm infra guy. I'm managing 20 tools. I don't want to learn 20 tools programming languages. Like you said, no ARM and cloud formation and Helm package. I don't want to learn.
correct.
So what do we do in this case? What do we
So
do in this case?
yeah, in this case, we should find the common solution, cloud agnostic one, like Terraform and Ansible,
No,
or
but we are designing the system.
yeah,
Remember the concept is we should not use the Terraform at all. Forget about the Terraform. We should design ourselves only. Let's say your organization decided, hey, we should have your own tool for it. We'll design. Okay. So now you have understood that we have a multiple platforms, multiple tools, multiple applications, and multiple different way to code for it. That's a problem for me as a infra guy, right? So what should be done? So if I design a system, then what I see common in everything. Please hear me out clearly. What I see common in every tools, common in every tools, and that is like all these tools are supported by what? One unique thing, and that is what? API.
yeah, yeah,
Correct now?
yes,
Just a second. So here AWS supports API, yes. Azure supports API, yes. GC supports API, yes. VMware supports API, yes. Kubernetes supports API, yes. All the tools should support API. That's a prerequisite. And now, if you look at this, any tools, you go for any tool for the sake of discussion, you will have API support for sure. And you know what? API language is very standard one. Okay, so API language is very standard one. Anyone would like to tell me what is the API language? What functionality you do with API? Let's say API, there's one function. What do you do with this function? Anyone? API function? One function. I'm not saying 1,000 functions. Let me tell you, Azure has more than 4,000 functions, APIs functions. AWS has more than 5,000 functions. All I'm asking is only one function, tell me. Only one function. For that, what we do? Same thing we do with all the functions.
It's
What
a
we,
call basically for that resource which you want to trigger.
what we do with the one function? Let's say today I'll say, hey, I develop one software, one function, one microservices, and I give it to you. What you will do with that? What you can do with that? All of
so I can
us.
call, yeah, I can call the APIs and
Export some kind of
yeah,
interfaces.
just
Yes.
call the API and get the proper information what I need for
That's what I'm saying. That's what I'm saying. That's important thing. What you will
yeah.
do with that? API address, I give it to you. Access, I give it to you. What you will do with that?
So I will call that API with my language, and I can get the information. Suppose say I have 100 VMs, so I need to get the what's the MAC address. That is my
Yeah.
requirement. So
Yeah.
I will the API and get that API calls function, and that function will give the output, and that will present in our output format.
True. Yeah. Maybe I should add also. See, any API, you get it anywhere on this planet. You will do only one thing.
We'll access it.
Correct now? You will do only one thing. CRUD you will do. What is the CRUD means? CRUD means create. Either using that function, I'll create some of this, create function, read function, update that resources or delete that. Simple. We don't do anything else. CRUD. In HTTP verb, we call it create means what we call it? Host, get, update, maybe put, and delete. This is the same thing you will do. That means what you are doing in here, you have API, right? Any function, let's say you want to create a AWS EC2 instance. So you will call this create or read or update or delete. Means create a virtual machines on Azure, read the virtual machines on Azure, or update the virtual machines on Azure, or delete the virtual machines on Azure. Simple. Are you understand? Correct now? Every API will do something. Okay, so I got to know, okay, one thing while designing the system, all these services we have different platform supports API. Now my challenge is I'm very selfish and lazy person. What I want to write only one programming language. So this is the one language. I write it whatever I want. I want some resources on AWS, some resources on Azure, some resources on GC, some resources on VMware, some resources on Kubernetes. I want all these things, but I want to write in one programming language. So now the question is very simple. I write one programming language. How this language will be understood by this API? This API. How do we send this request? Forget about authentication. Okay, authentication anyways will have it. How can I send this code which I write in one language to the AWS supported code, Azure supported code, GC supported API call, VMware supported API call, and Kubernetes? That's the problem we are trying to fix it. So if I design this system, then what we will have, because AWS is have a different standard, Azure have a different standard, GC has a different standard, Kubernetes has a different standard. So what we should do, I will write one tool here. I'll write one tool here. Think simple, okay? And I will send this code to this tool. Okay, very simple. So I'll send this code to the tool, and I'll say, hey, this is what I want. This is my desire. This is me. Okay, this is what I want in my infrastructure to be shown. Okay, so this is my desire. I give it to you. What this tool should do? This tool should bifurcate the code actually. Okay, this code is for AWS, this code for Azure, and this code for the Kubernetes. So this tool I need to develop. Correct now, all of you? This tool we should develop. So different one code I write it, but this tool should that divide that code in a different the platform wise. After that, conversion should happen. That means this I write in one language, right? But this language is not understood by AWS. So what will happen? While sending this AWS code to AWS API or Azure code to Azure API, same goes with the rest of the things also. What it should do? Conversion happen. Conversion should happen. That means it should be as per the supported API. So this code should be converted. Think simple, okay? So here there's one conversion tool I'll write. There's one more conversion tool I'll write. There's one more conversion tool I'll write. There's one more tool I'll write, which will convert my code to this AWS support code. So the flow is very simple, guys. Here I'm writing one simple code, one code where I'm expressing all of my desire, which I want to see in my infrastructure. I send this tools to this code, this code to this tool, and this tool will take care of the sending this AWS code to the AWS tool or Azure or GC or Google. Okay, and after that, this tool will send that converted code to this API of AWS, which is understood by AWS. This tool will send that Azure also the same code, which is Azure can understand, GC can understand, and then same goes with the Kubernetes can understand. Are you understanding the logic, all of you? All of you?
Yeah.
Yeah.
So I think this architecture will work. Don't you think so?
Yes.
So what we should do? So what you should do as a team, we will write one coding standard for this. One coding standard. for this. So we'll write one code, just like you write a Java standard or C++ standard, Python standard, like that. We'll write one coding standard, which will be easy for people to write. You have a YAML also, you have a JSON also, but none of these. We want more simpler one, more simple. XML also we have it. So how many coding standard we have? XML we have, JSON we have, YAML we have, Python we have, Java we have, but we want none of these. Why? Because it's like too much. I don't want to do all this coding actually. I want to do more simpler coding, more simpler way to express my desire. So we will design one coding standard which will be very simple to grasp by anyone. So that's one work we have to do. Now we have to write this tool which will read the code, my code, and transform the code, send the code to the next tool for their processing. Correct? So this is the, let's say, one tool we have to develop, and then after this we have to develop this tool also, which will do the conversion of my code to the platform ready code, platform supported code, and then do the work. So this is the something which you have to do. So now guys, I think you know what, if you have understood this problem, then I think you know what, Terraform also has the HashiCorp also has done the same thing. HashiCorp is saying, hey, listen, I am allowing you to write one simple coding standard, which they call it HCF. HCF. What is HCF? Anyone have idea? What is HCF means? HCF means? HCF means HashiCorp configuration language. That means any product which you use of this one, any product of, if you use of HashiCorp, you have to use HCF only. Very simple to write, very simple to share, simple to test, simple to debug, easy to test, debug, and share. SCF, please remember, configuration language. Okay, so what they did, they defined one configuration language which is very easy to learn, test, debug, troubleshoot, extend, share, all these things. And after that, they developed one tool, and that is called, you know what? Terraform. Yeah, Terraform. Yeah, you are correct. SCL. HashiCorp configuration language. By mistake, I typed SCL. My bad.
Okay.
Yeah. So Terraform. So what is the role of Terraform? You understood? Role of Terraform is to receive all the code which is written in SCL and then send it to Terraform. And Terraform will transform that code and send it to the another tool, which we call it a provider. Provider. In Terraform, we call it provider. So what this provider will do? This provider is AWS provider. This provider is Azure provider. This provider is GC provider, and this provider is Kubernetes provider. So what they will do? This code they will send it to the AWS provider, and AWS provider will send this code to the API of AWS. And if authentications are correct, this code will perform here and give you the response. Are you understanding, all of you?
Rajesh, this provider is nothing but modules.
A
Like if I
provider,
want to run
this
the code,
provider is nothing but you can say it's like a tool.
Those are cloud providers, right?
No, it's a tool. It's a tool means some executable. This is a tool also, and this is also a tool, and this is the code. Okay, tool means some executable, some applications, some software, like that. Okay, so this is for conversion. Remember that. So theoretically, if you understand, this whole thing should be in your laptop right now.
Okay, so Rajesh, I have a question. Okay, normally when we write any code and all or anything, so on top we define provider. Maybe we can use Azure or AWS there, right? Or anything.
Right.
Yeah. So when we write or when we mention provider over there, isn't it while like we are trying to what to redirect or that yeah, this is my provider, because here you are saying it is a tool. So means like, could you just elaborate how that works?
So understand that I've been telling you, think logical. I write a code in one language, which you call SCL, correct? I send it to the Terraform, which is a kind of collector of the code, you can say. And Terraform responsibility is to convert that code as per their platform. So Terraform is not doing that one. Why? Why Terraform is not doing? Because guys, in infrastructure, if you look at this, there are thousands of tools. If you see that all the logic they incorporate in a Terraform only, then Terraform will become a 5 GB of code actually. Are you understanding? 5 GB of code, which is not possible. Terraform don't, and on top of that, HashiCorp don't want to do that. Why? Think simple. HashiCorp, if they start incorporating the and start converting the user's code into the API supported code, then it will be a problem for HashiCorp. Why? Because they cannot never do that. Every week we have a new tools. Every day we have a new release of the thousands of applications. So HashiCorp cannot do that. So what? Who can do that? Those who are writing APIs for it. For example, AWS, they knows their software well. Azure, they knows their software well. So they will write some software which can convert this code, special code, SCL code to their supported code. And that's what has been done. So if you look at this, all these provider, not HashiCorp has written. AWS is the first provider which was written by HashiCorp. Rest of this provider was written by the platform itself. That means, let's say you have IBM products, so you will write. You have a Adobe product, you will write. Let's say you have a AWS, you will write. If you are Azure, you will write. If you are GitHub, you will write. Those provider. So those provider will convert this standard code to your API supported code and get the work done. Are you understanding? So here, this tool, the one which you see provider, is a tool, it's executable. I'm saying it's very straightforward. Okay, so this tool will take the code received from the Terraform, and then they will do some sort of checks. And after the checks, they will send that code to API of AWS. Are you understanding all of you? Hello?
Yeah. So yeah, yes, Rajesh. Okay, so you means like what you said, like okay, Terraform has written only one code for platform, that was like only for AWS, right? Remaining all were written by their own like
Yeah,
by the
so
platform itself.
HashiCorp has written one provider officially. After that, any other provider which was written in cooperation with, you see that here, no? I showed you that page here. See here. Official. Official means is from the company itself. Verified means HashiCorp has verified these are the providers which can be used. Community means from the people. Okay. So like what is that? Okay, someone is speaking. Probably you can mute yourself. It will be easy for us.
Please mute yourself if you are not.
Yeah. So are you understanding? All of you?
Yes, Rajesh.
Yeah. So now look at this, guys. That code which you write plus Terraform plus provider should be in your laptop actually. Okay. These three things should be in your laptop. And after that, if you have a right authentication of AWS or Azure or Google Cloud or VMware or whatever it is, here you see. Okay. I
Rajesh,
think
there is
I need
some
to mute.
disturbance. Can we ask him to please mute? Okay, if you are the host, can you mute him, please?
Yeah, I mute everyone. Yeah, guys, please take care of it from the next time. It'll be easy for us. Okay. So this is the stuff. So now, guys, here in this architecture, you have to write one code, which is HCL code. I will correct this. This is HCL code, HashiCorp configuration language. Okay. And after that, this code you will send it to what? Send it to Terraform, and Terraform will send this code to as per the provider, and provider will see that right code. If it is right code, will send to the AWS, and AWS, if authentication has been provided, then do the or Azure do the resource creation or deletion, whatever you have asked. So here I said, right, what you can ask API always, what you can ask CRUD. You can ask only CRUD. So here we have a 3 ways. So here understand that who will request whether you want to do the CRUD. You will request, this is the guy who will send this code and say, hey, I want to create these resources. Or you will say, hey, I want to delete these resources. Or you will say, hey, I want to update these resources. So you will send this code to the Terraform. While sending the code, you will send this instruction. But the question is what you will set. So you will say 2 things, apply and delete. Okay, delete. So apply means what? So apply means create. Okay, I'll just give the space, and plus update. Create plus update. And delete means what? Delete means delete, simple. Then you will say, Rajesh, okay, I understood that. If I want to create some resources or I want to update the resources, then I will do the apply. If I want to delete the resources, I will run this command called delete. But what about reading? Correct now? All of you? What about reading? Hello?
Yeah.
Yeah.
So there is a 2 commands which we got it, apply and delete, which you can use for the create plus update plus delete. But what about deleting? So understand that, guys. Very simple.
Plan. We use plan.
No.
Or
Just a second.
init.
Just give me 2 seconds. Yeah. So here, for that, what we'll do? So understand that. See, read you can do, but little bit different way. How? So understand that whenever you make any request to the API, first thing, please, I'm asking all of you. First thing, tell me that when you make a request to API, which is the most preferred way to make a request to API? What is the most preferred way? Please tell me.
You mean HTTP call or a Postman
Okay,
gate?
maybe I'm confusing you. Most preferred way means the format of request should be JSON, correct?
JSON. Okay.
Yeah. So guys, when you respond also, API respond also. When you request to API, they will respond also. So they will respond back. Okay, I'll change the color just a second. So they will respond back also. This is our row. Look at this. Any request, you'll get a response for sure. It can be anything. I don't care about the response. But that also you get in a JSON. So now you know what, guys? JSON, whatever the response you got it, this Terraform are supposed to gather all the response and stored in the file called state file. What is the called state file? This is response. What it contains in the state file? All of you will remember that, right? State file is containing the response of what? Response of API. Please remember that. State file, there'll be one state file will be there in your same directory where the code is there. Okay, so that is a state file. State file will contain the response from the API. Now the questions to all of you, I'm asking, can you please guess that what is the state file format, the content format?
Generally stored as .tf.
No, format. Okay, sorry. I said extension now. Format content of the file.
I think it's JSON.
It's a JSON, correct? Yeah, it's a JSON. So now you understood one more component. This is also JSON. You should not touch this file. Why? Because this is a response from the API. Okay, so response from the API. So how do I see? How do I see this file? So you can open up that file, you can see directly, but there are few commands are also there, like a show or output and all stuff like that. We'll get into that. So this is the things which we have. So now it's very simple architecture. I was talking about architecture actually. So how it works? What is a Terraform architecture? So typically what we do, we as an individual, we want to write a code. Okay. So for that, what we decided, we use the SCL, HashiCorp configuration language. Very easy to write. Don't worry about that. Okay, very easy to write. We'll write a code. Whatever I want to see in the infrastructure, I'll put it in this code. Okay, how to put it, I'll talk about next. I'll put it in this code and I'll send this code to the Terraform with my desire. What? Desire it can be apply or delete. Apply, delete, apply, delete, apply, delete. Seeing the later point of the time. Okay, and after that, this Terraform will accept all this code, see that all this syntax error and this that and all, and send this code to the different provider as per the request. This provider will make an API call with the request saying that okay, I want to create this VM or delete this VM, whatever it is, or VPC. When I say VM, I'm just giving you one example. Azure have a more than 4,000 resources to create. VM is one of them. Let's say you create a VM or network or storage or load balance or some domain services or anything, whatever you want to, you want to get it, you can do it. Okay, and then API will see that if the request is genuine, access is genuine, which you have given. So they will do the stuff and they'll send it back to you as part of the response. And Terraform will store the response in state file. So in that case, yes, what we have to do, we have here first thing is we have a human write a code which is a SCL code, and SCL code sent to the Terraform send this code to the providers send that to the platform API. Platform is a platform I'm saying. Okay, and then response you get it, which is stored in the state file, and this is the whole work is being done. So did you understand the architecture, all of you? Anyone have a doubts, questions, and stuff like that?
Yeah. So, Rajesh, once information is stored in state file, then what next? It will convert that with our readable format, the output.
JSON is always readable format, okay? But we are very lazy people. We want to see a little bit more easy way. So yes, so there's a command for it for everything. So that's what I'll talk about it. So and this one output command and all. So I don't want to confuse you with too many things right now, but it's like that. So many commands are there.
So
So
Rajesh,
this provider, Rajesh, this provider is like a plugin for individual cloud service provider. We need to install this provider.
Yes, this is a plugins actually. Plugins, we call it plugins, but plugin has a different kind of plugin. Provider is one of the kind of plugin. For example, let's say you have asked, so I'm just reminding you. There's a remote provisioning plugins also there. Provisioners are also there. That's also called plugin. But I have not explained you the provisioner. Let's say backend plugins are also there, but I have not discussed about that. So I don't want to talk about the plugin concept right now, but providers, let's call it this one. So you can say it's a conceptually it's a plugin itself.
Okay, thank you.
Yeah. So Rakesh, my question is, since we have different type of versions are there, right? Community and cloud and enterprise. So this all three, like provider and Terraform and SCL code, it will be installed on the source machine, right?
Yes, that's correct.
Okay.
Every time you need a one you can say one machine where you will have a code plus Terraform plus provider. That machine can be any machine which you like. For example, you will begin with in your infrastructure, you will have this code in your laptop, but going further, maybe some CI/CD, you will have some build agent. There you have a code, or maybe somewhere else also.
Okay. So once I have prepared the, you mean all three versions have the same architecture, even though cloud and enterprise and community?
So see, the cloud and enterprise, the use cases are different little bit. See, let's spend 2 days with Terraform, then you'll understand the problem. If you have a mindset as such like you are a CTO of an organization, or if you have a mindset such as you are an enterprise architect, then you will have a problem automatically coming with a Terraform this implementation. Then we'll say, Rajesh, you are saying the code will be located at one place, let's say in the build agent, and everyone can see the code. How can I protect that code? So this kind of problems you'll have it. Like not what project one should not see the project two codes, project two should not see the project three code. In a project itself, someone will have a full access, someone will have a minimal access. Managing the credentials, that's one problem. Managing the code at one place, that's one problem. Multiple problems you'll have as an enterprise architect or a CTO, and then we'll have a solution also with the enterprise or cloud version. You'll say, Rajesh, I want to store all the logs of run from last 6 months. So this model, you are not getting the logs. It's an individual model, right? One person can run this, but how do we store the logs and all? Are you getting my points?
Rajesh, this provider will be like tightly coupled, or we can say like embedded with the Terraform architecture, right? Not with the individual provider, the actual provider, AWS, Azure, or GC, right?
Sorry, this question I did not understand.
Okay, so this, in the architecture, right, we have this provider which interacts with the individual provider, AWS, Azure, GC. This
Yeah.
provider comes under Terraform architecture. It's tightly coupled with this architecture. Or it gets embedded with the individual provider, like actual provider, AWS, Azure, GC, VMware.
Okay. I'll create this clear statement. When we say, understand this, sir. When I say AWS provider, okay, so it's a one executable. That's all. When I say GC provider, it's one executable.
Right.
When I say AWS, then you know that. When you say Azure, you know that. What is Azure? You know that very well, more than me. What is AWS? You know that very well, more than me. But when I'm saying provider, is just one executable which will transform the code which has been written to the API supported code for that particular platform for the sake of AWS or Azure. So Azure write their own provider, which we will download and keep it, use it. AWS will write their own provider, which they have written, and then we will use it and keep it in our laptop for the sake of discussion. I'm not getting into the enterprise section right now. Let's the starting problem. So when I say provider, it's like executable, simple. When you say AWS provider, we'll get one executable from AWS, which can help us to transform our code, Terraform code, to their API, to their platform supported code. Simple.
Right, but the actual owners are AWS, Azure, GC. We are just using that utility, or maybe we can say like executive tables for our purpose.
That's correct. These providers are managed by their own company. For example, there's one product which is called Kubernetes. So Kubernetes provider is managed by Kubernetes community or CNCF itself. AWS provider is managed by AWS team. Azure provider is being managed by Azure team, Microsoft team. Now you say, are they the owner? No, they are not the owner of that provider. They are the contributor actually. That means the hundreds of contributors has come together around the globe and develop AWS provider. Like that, there are hundreds of other contributors has come and for Azure and they have developed. Azure only guided them because Azure is their product, right? It's Microsoft product. So if they are not participating in those development, then who will take care of it? Because they are the owner, they know the architecture, they know the API call and all the stuff. So other people also have coded, but it's like theoretically I'm saying. Are you understanding?
Yes, got it. Yeah.
Okay, so now this is the how the Terraform works. So remember that what you need to do, you need to install Terraform first, you need to install provider second, then you need to write code third. Okay, and then three things together, and after that you do whatever you want. Write a code for infra. You want to write a code for infra of AWS, Azure, GC, VMware, or Kubernetes, or 2200 something which I showed you. Go ahead and write it. Sorry, this is a filter applied. Go ahead and write it. Here. Understood, all of you? So what is your job? You need to write a code. That's all. And this code is very simple to learn. That is, I'm going to teach you how to write a code. Okay, all of you understood that, right? Okay. So now, guys, there is one concept we have here. I want to tell you that Terraform workflow. Terraform workflow. What is a Terraform workflow? So, guys, tell me one thing. When you really run the code in infra, before that, don't you validate all these things are correct or not? Settings, what will be created, what will not be created. Am I doing some mistakes? So what do you do before that? Before running the real code, what do you do in practice?
We do like we test it, or like in Terraform we do a plan or init, I think.
Yeah. So what I'm asking, what I'm trying to tell you guys, I'm asking is, see, if you run a code before that, don't you think you should do some dry run? Correct, na? Dry run. So dry run is like, it's not create a resources in real, but it will tell you what are the resources may create, and it may not create or update. Well, I'm not saying only creation, okay? It can be update also, it can be delete also, it can be anything. So first thing, what you should do, plan, Terraform plan. Okay. Okay. That's a dry check, dry run. Okay. Remember, after that you do apply, and after that you do the delete. Are you okay? All of you? So these are the three workflow, which is very popular. We use all the time. Plan, apply, delete. Plan means dry run, apply means create or update, and delete means delete those resources. Are you comfortable, all of you? Okay.
Yep.
Now, next thing, guys, you will have questions. Rajesh, tell me, how can I download this provider? So how can I download? How can I teach you? Because downloading is simple, right? Everyone can download and keep it in a certain directory structure, and then go ahead and use it. For example, Windows will have different exes, Linux will have different exes. So you can download and use it. It has to be in a certain directories, that provider. But this task will become more easier, when you use the command, because we don't want to do the things manually, right, nowadays. So what to do? So guys, there is one command which is given by Terraform, and that is called init. Okay, so init will download the provider. It's a one-time activity only. Okay, so that means if you start working on it, then first thing what you have to do, init, download the provider. I'll teach you, don't worry about that. Then plan, which is like a dry run of your code for the various platform. And after that, apply. And if you think, okay, the requirement is done for the infrastructure which I created, or then delete. Update also you can do through the apply. So will you remember this command, guys? Terraform init, Terraform plan, Terraform apply, Terraform delete. These are the 4 commands which you have to remember today. That's all. That's all. So are you comfortable, all of you? Okay. So now, guys, let's conclude the session. What we discussed. We discussed what is Terraform. Then we try to understand what is there in the infra. Whatever you think of is there in infra. And we have why we need it. So I told you, because we love Terraform because of this 2,255 providers. Okay. And how it works, we explain it to you, this image. I'll share this notes and image also. Though we have hundreds of slides also. 100 slides are there, which I'll share with you. Right now, I don't feel going through the slides. And we understand the concept of API CRUD also. Remember this concept always. It's not something I'm teaching only for the Terraform. Anywhere you go, API, what to do, CRUD or post, get, put up, delete. This is something which you are trying. This is a CRUD only. Okay, to the API. Which API? Here is API. Here is API. Okay, and that's all. So now next question, what is the next question? Next question is how to write Terraform HashiCorp HCL code. I will not say Terraform, HashiCorp SCL code, which will contain your desire. This is the next topic. Though we will install the Terraform also, that's not big deal. It's a very simple things to do. And the important thing is how to write this code, which can code for infra. Okay. So any questions we have? Any questions? Any doubts?
Rajesh,
Yeah, please tell me.
yeah, like could you just please brief a little again on the CRUD part,
CRUD
especially the
means,
R.
R means read. Read means, this which I said is an API call. That means if you make a call to any API, you do the CRUD or get, put, post, and delete. Now in Terraform, how do we do that? Using the apply and delete. That is what I'm. Now reading purpose, for that state file you can read it. There is a few commands for that. Output and show. See this reading this file, you have to do that because the response is here, right? So you should not ask AWS because because anything which you have requested, you got a response and stored here. So you should start asking state file. So state file is in JSON format. You can see manually also, but most of the time you use the command to read that. That command I've been repeating multiple times. So that's what. That's a get. That's a read. You have any specific questions on this? Anyways, during the demo, I'll show you all this stuff. But any specific questions for that?
No, Rajesh, thank you.
Okay, reading means what? Reading means what? Let's say you create one virtual machines on Azure. So I want to know IP address. I want to know which network is part of it. I want to know the all this meta information for this VM. I want to know which network, which subnet, which availability zone, which region, what is our private IP address, public IP address, how to log in, which key has been used, which password. All this is the meta information. So I want to read that. I want to get it. Correct? Whatever you created, you should get it, right?
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.
Hello everyone. If you would like to access the remaining videos of this playlist of 50 plus more tools which are coming under DevOps, DevSecOps, SRE, DataOps, GitOps, etc., kindly become our channel members by clicking on the joining button. You would have access to 100s of playlists and 1000s of videos lifetime access with this membership. Enjoy.